Bismillahirrahmanirrahim. The transactions and the work with transactions is one of the very famous security perspectives that the T-SQL has brought to us. So actually, we know all the details that will give us the chance to build up a secure transaction, a secure one transaction. And all of the transactions we can refer to, and we can analyze and audit them security-wise. Mainly when you talk about the transaction, means we are going to set to pass or to retrieve a query. We are going to pass a query to the server, or we're going to retrieve data from the server. So in all cases, we are dealing with the SQL only, but in different structure than what we are habituated to. When you pass through the course, database management system, we are seeing something differently. But all is on the basis of the SQL only. Give me a second, please. So the main purpose behind actually securing a transaction is the group of properties that we're going to summarize behind the four properties we see in front: atomicity, consistency, isolation, and durability. Briefly, I'm going to pass to summarize them to you just to refresh your minds. Right? We take an example of a transaction, and we are going to draw the four properties on top of. The case of the ATM distributor, let's say the withdrawal machine. Actually, we are going to make a withdrawal. A person comes to an ATM machine, and he tries to make a transaction, a real-life transaction. So the system actually has to pass through systematic steps to finalize this transaction. The person who is ever trying to make the transaction has to identify himself to the machine. So the system has to check the validity of the requester by checking his account. Who are you? which account you are referring to. Then the account, does it have enough balance to provide you whatever you are requested? Then the actually the action of the giving you the money, the withdraw, and also an update would happen to your validated account. So validating your account, checking the balance if it's available or not. You are asking, for example, for 50 riyal, and your balance having 40 riyal. It's not fair. It will not give you money, but it has to check the balance and give you up to the limit of the availability. Yes, it does the action of giving you the money. Then the update of the account checked already. So in the sense of if you withdraw 1 riyal, so it has to be deducted. If you withdraw X riyals, whatever the number is, it has to be deducted from the available balance. If nothing happened, the account has not to be updated. This update has not to happen. Those 4 tasks, if one has to be to fail, all of them, they have to fail. It means either to execute them all, or they have to fail all. It means there have to be a rollback. It means actually you cannot fail the checkup of the account, but we can cancel. The system has to do actually this step of cancel this step. So this way, seeing those 4 transactions all together as just one process is an atomic approach to the transaction in question, which is the withdrawal, the money withdrawal. Thus, the atomicity is one of the properties that we have to ensure it's available and it's respected and is guaranteed within a given transaction, or whatever, since we are talking about the security and a secure transaction. Seeing all the queries submitted through a transaction as atomic as they have to be is one of the very basic features, properties that we have to guarantee behind the transactions in order to secure them. So in conclusion, atomic transaction means all the queries inside, they have to be seen all together, executed all together, and if one fails, the others have to fail also. And the context of failing here means there have to be a rollback. Why I'm saying rollback? Rollback means to cancel and come back one step to the initial states, because we cannot we cannot fail the checkup. So if the checkup has happened and something happened at the withdrawal level here, so we cannot fail this one, but we can cancel it, we can roll back, we can lock the account, we can switch off, and so on. So in all cases, there will be no harm, and thus the security has been guaranteed, since there is no harm, no misfunctioning of the total transaction. Yes, good. An example of an atomic transaction, via which we see actually here. Just I'm gonna these the paths behind this atomic transaction. which is actually a list of data insertion. We are inserting data, multi-valued, list of values to one entity, name it table 1 or T1. We are creating here actually one table, and we are given the structure. Create a table that has only one field. Data type for the field. Okay, just one field only. What? One field only. Okay. We have this entity, and the name is T1. If we can maximize the font. Great. So the entity is T1. With one field, we are going to utilize to pass to insert queries. The purpose is that this transaction here we are going to do has to happen totally or not, either to pass them both or not. Means we have to say we have to insert those two. We have to execute those two insert statements, or we fail them both. Thus, we have to guarantee the property of atomic, of being atomic. How it has happened? How it has happened? Actually, we created a procedure. We given it a user-defined name, and to the procedure itself, we are passing the first global variable and the second global variable. Why I'm saying first global variable, both of them, because we are passing them at the level of the declaration of the procedure, as if we are passing a parameter. So parameter number 1 in the functional programming and procedural programming, parameter number 1, and parameter number 2. The data type is an int, and this one also the data type is an int. Okay, the body of the procedure is this block. So the content of the procedure is this thing. We are actually given an administration level to the session in question, to the one who is executing, the owner, and the content is we're going to pass these two statements, which is to insert the value of the variable 1 to the table T1, since he has only one field. Since he has only one field, and it is from the same data type, it's an int, like this global variable 1, global variable 2, and the same thing for the second statement. We are passing the value of the V2 to be inserted to the T1. So in both cases, they are very perfect, and they are correct, coherent. We are inserting an int to the field C1 from the T1, and we are inserting another int to the field C1 from the T1. This is the C1. Great. So this way, we guaranteed that those two, they are controlled by this procedure. By this procedure, EDB, which is actually a user procedure T1. This is a schema, and this is a schema, the database owner. So we are passing, we are creating a procedure that actually is covered whether the same schema where the entity is. It is another security view from the same. They are from the same scope. Yes. So far it's guaranteeing that we are going to pass the values. globally to the user-defined procedure here, and we're guaranteeing that those two they will be executed. The last thing is to execute this procedure. If you can see here actually with me, the keyword exec, the user-defined procedure, and instead of the global variable v1 and the global variable v2, two ints, two numbers. So we give any number here and any number here. It has to be from the data type big int or int. It's an int. It's an int. So we are passing two values to the user-defined procedure, and those two variables those two values, they would replace what those variables are pointing to. This way, those two insert statements would be executed all together, and if they fail, the stored procedure would fail. Means both they would fail. Atomic. These are one of the good examples where we see an atomic transaction or a transaction being atomic. Any questions, please? Okay. Okay, great. So we continue. The second, the atomic, actually, I insist that we are seeing an example here, and I given it enough time for you to interact, because actually it is a view that we have to see it again and again and again and again, and it is one of the properties that we have to insist on. It has to be available clearly once we talk about the secure transactions, or the T-SQL secure transaction. The consistency, it is a sense, it is a context of driving the full scenario from the beginning to the end without any alteration. Means either we reach the end of the transaction, we admit, or we roll back. It means we cancel all what we did as actions. We do not have to actually execute half of the transaction, a given transaction. No. If something happens in between, we give usually the same example of the ATM machine. If the electricity or a shortcut has happened in between when a transaction is being executed, so the effect has to be rolled back. We don't say that the customer has got the money, withdrawn the money. So, the machine cannot make an update because the electricity has shortcut. No. There have to be a scenario to guarantee that even if a scenario of electrical shortcut happens, the rollback has to be possible. It means once the electricity comes back, the ATM machine has to roll back all the events and has to report that if the money has been withdrawn. So there have to be an update. And if the money was not withdrawn, so the transaction has to be cancelled. That's it. There will be no update to the account, to the main account. Do you get the point here? The third one, the isolation. I come back to the same example. Where we see the atomic scenario. Those two insert statements here, we cannot execute the first one. The computer has not, actually, it's not we cannot, but the computer does not have to execute the first one. Stops and passes another transaction, transaction 2, transaction 3, and so on, and comes back to execute the second insert. No. This start procedure has to be isolated from other transactions, in the sense of once the execution or the call and the execution has been launched here of this stop procedure, the full body has to be executed without any interruption. This context of executing the content without interruptions would happen actually because of the isolation property. There have to be a scenario we wish to guarantee that the totality of the DML, data manipulation queries, has to happen all together, since they are belonging to the same scope, which is the same procedure here. This is an isolation. So query 1, query 2, and if there are others, they have to be all together executed in a serialized mode. This is actually an isolation. It means if there is another transaction, there will be no interruption to this block to guarantee that this block would be executed safely and securely. So there will be no interruption to this block here.
Are you there?
Just a second. So we pass to the fourth property and the last, as durability. All the properties we saw so far, so the transaction has to be atomic, and it has to be consistent. It has to show the consistency, and it has to be isolated from other transactions. Transactions means there has to be no interruption, no interference. All of them, they have to be actually not related to a specific account or to a specific session, specific user. No, they have to be valid for all. Means if a user one actually wishes to execute his transaction, the system has to execute the list of the transactions for user 1 with the respect of the atomic property and the consistency property and the isolation property. It has also to provide it to user 2, user 3, and to all the users. So those properties, they have to be actually validated for all users from the same level. It does not have to happen for one and fail for another user. While the user from the same group, for example, you say students, instructors, or whatever. So the list of the tasks to be executed and the respect of the atomic property and the consistency property and the isolation property is not related to a session. It has to be based on a service. So since the sessions, they are with the same level, they have those properties, they have to be respected for all. For all sessions with the same level. When you say administrators, so all the administrators, they have to have the same properties. When we say users, all the users, the current users, they have to have the same properties altogether. This is the durability. Summary to this acid properties, to those acid properties: atomicity, consistency, isolation, and durability. Those properties, they are guaranteeing that a transaction will be secured at a high level. Does not mean that it would be 100% secure. Vulnerability is usually available and data checkup has to happen usually. Yet, respect to the acid properties on a transaction would raise up the security of that particular transaction. So we respect the atomicity. It gives us a more secure transaction. Without the respect of the acid properties, the transaction might happen. Means the execution might be done. Means the queries might be submitted to the database server, and the data might be manipulated. Yes. At the same time, issues are raised up. Interceptions might happen, and consistency might not be guaranteed and might be failing. If you take the example of the ATM machine, if there happened a shortcut, electrical shortcut, while the money has been withdrawn, there will be no update. There will be no update of the electricity once it came back. So the money is withdrawn, and the account is with the same amount. It's a failure to the company. Thus the acid properties have to be respected and adopted for security of all. The user and the provider, the consumer and the service provider. Remember, we are having 4 properties: atomicity and consistency, isolation, and durability. Each describes a list of actions that have to be actually respected. I'll stop at this level. Next we'll see the transaction modes and the isolation levels. Any questions so far? If you hear your name, please